In learning target 3, we're using exponent rules or exponent properties to solve equations. And that applies to two different scenarios. One, that's where you have an exponent with your variable, and so you have to get rid of that. Other scenario is the exponent is in the variable, and that's an issue. Okay? So we're doing both kinds of those things. All right, so let's start here first. So if we're going to solve y to the 4/5 power equals 34, we're trying to get y by itself. We get that. Okay? I'm going to show you two different ways to solve this. Some of you guys might need to do it the long way, then you'll understand the short way, but so long way first. Using our radicals and our exponent rules and everything from yesterday, I could rewrite y to the 4/5 as the 5th root of y to the 4th power. Right? I can rewrite that from yesterday. Any questions about that? Then I think it makes more sense about how to solve it. So if I'm trying to, looking at what's going on with the parentheses and stuff, I'm trying to get rid of the 4th power. How do you get rid of the 4th power? Take the 4th root. So I can take the 4th root of all of this. That means I have to take the 4th root of 34 as well. Right? But so now I have the 5th root of y equals the 4th root of 34, which is a decimal, and we'll get there in a second. So now I have the 5th root of y. How do I get rid of the 5th root? Get rid of the 5th root, you go to the, how do you undo the square root? Square something, right? So get rid of the 5th root, we go to the 5th power. So now I have y, and I have the 4th root of 34 to the 5th power. And I can figure out that value. I can use my calculator. So if you're using the 4th root, you do 4. You go to math number 5, where it has the x root. Make sure you type in the 4 first. And you raise that to the 5th power, we get 82.1. Questions about any of those steps that I did there? That's one way to do it. The other way to do this. We have y to the 4/5 power. I need that to be y to the 1st power. So I can raise both sides to the 5/4 power. What's 4/5 times 5/4? 20 over 20, right, which is 1. And then I have 34 to the 5/4, which is just the 4th root of 34 to the 5th power, which is what we had right here. Right, so we still get y equals 82.1. Right, so the second method is way shorter, but I need you to understand how that works. It's not just like, oh, we just did some stuff. Like, all of these steps are being done by raising everything to the 5/4 power. Any questions about that one? Can I erase what I've got? On the second example, we can use the same exact method, but what do you have to do first? Subtract 5. Right, you can only do, we're raised to some power as long as we have x by itself, right? We have x to 3/4 by itself. So we have to subtract the 5 first. So now I have 729 equals x to the 3/4. And you can solve that the long way or the short way. Both ways would work. I'm going to go use the short way. It's going to raise everything to the reciprocal power, so the 4/3 power. I have 729 to the 4/3, which you can type into your calculator. Or you can rewrite it as the third root of 729 to the 4th power. Both of them are the exact same. So I get 6,561. Any questions on this type of equation? Again, in this case, you're just solving for x, y like normal. You just have to get rid of the exponent. On the rest of learning target 3, you have equations where you have a variable and the exponent. So in order to solve these, you have to get the variable out of the exponent. All of these can be solved using exponent rules, right? So you have pretty much one of 3 scenarios. No matter what, if you're going to solve any of these, the base has to be the same. If the base isn't the same, you can't solve it. So for the first one, we have 3 to the x plus 5 power equals 3 to the 8th power. You have the same base. You have a 3 and a 3. So if these are already set equal to each other, then shouldn't the exponents be equal to each other? So you have x plus 5 equals 8. You don't have to even worry about the 3. So what does x equal? 3. No big deal. Right, that should be the easiest kind. Right? Everyone's already matched up. On the second one, though, you don't have the same base. This only works if you have the same base. So you might have to manipulate some of them. So you have 4 to the x minus 3 power equals 1,024. I need to rewrite 1,024 then to be 4 to some power. Or if that didn't work, we might need to change both of them to 2 to some power. Okay? So I'm pretty sure it's 4 to the 5th power. 4 to the 5th power is 1,024. If you weren't sure, you could try a few of those out in the calculator, right? It's always not 4 squared. Okay? So you would try out until you get 4 to whatever power is 1,024. If that wouldn't work, again, you might need to change both of them. So you might need to have 2 to the 2nd power for a 4, and then 2 to whatever power for 1,024 if it didn't work. Okay? I'll do an example of that in a second. But so I can rewrite this, and I have 4 to the 5th power. So now I'm in the exact same boat as the first example. I have the same base. Since they're already set equal to each other, that means the exponents have to be equal to each other. So here x equals 8. Questions about that one? Okay. On this next one, I need to have the same base. There's already an exponent, but it doesn't matter. I can still rewrite things to the same base. So how do I rewrite 8 to be 2 to some power? Eight is 2 to the 3rd power. But now I have to worry about some exponent properties. I have 2 to the 3rd to the 4th. So what am I supposed to do with the 3 and the 4? Multiply them. So I have 2, the x minus 8 equals 2 to the 12th. And then I can set the exponents equal to each other. I need x equals 20. Because of some of the homework problems, I'm going to do some extra examples that are not in your note sheet. Because I want to make sure you guys all know how to do these. So as some extra examples, okay. If I have 4 to the x plus 2 power and 8 to the 5th power, I cannot rewrite 8 as 4 to some power. That does not work, right? So in this case, I have to rewrite both of these. Have the same base. So what do you think would be the one that we could use? could use 2, right? So 4 is also 2 squared. 8 we just talked about is 2 to the third, right? But now again, on both sides, I have to worry about my exponent properties. If I raise an exponent to another exponent, I have to multiply them. So on the right-hand side, I have 2 to the 15th. On the left-hand side, you have 2 times x plus 2. That means you have to distribute. Make sure you do that. So you get 2 to the 2x plus 4th power. That makes sense. Don't forget about the rules of exponents that you already know. So now I have 2x plus 4 equals 15, and we can solve the equation. Questions about that? If you had 3 to the x plus 7th power equals 1, you have to have the same base for this to work. How could you rewrite 1 to be 3 to some power? Three to 0. 1 is always something to the 0 power, so you make whatever base you want to the 0 power, right? So now I should have x plus 7 equals 0, so you have x equals negative 7. No big deal, right? But you should be able to rewrite them. They also start getting a little more complex on the assignment I gave you. So let's say I gave you 3 to the x times 3 to the 4th equals 9 to the 3rd. First of all, they're not all the same base. So what do I need to rewrite? 9 needs to be 3 squared to the 3rd. So that's really 3 to the 6th, right? Over here I have 3 to the x times 3 to the 4th. I need to consolidate this so we have one base. So if I have 3 to the x times 3 to the 4th, what am I supposed to do to those exponents? Add them, right? So don't get, that's really, I make the, you can see there's eraser marks on all of my key because I did that. I was going too quickly, right? So make sure you think of the actual exponent properties. So now I have x plus 4 equals 6. So make sure you're using the actual exponent rules when you're trying to condense things. And then one more example, and I'll let you get started on your homework. Let's say you have 4 to the 3x power, and then 4 2x equals 4 to the 8th. Right, everything's the same base, so no problem. I guess if it wasn't, you have to rewrite it. What do you do when you're dividing? Subtract the exponents. So make sure you think about that. So you have 3x minus 1 minus 2x equals 8. That's what's going to happen, right? You could rewrite it with the bases of 4 first if you wanted to. So 3x minus 2x is just x minus 1. So you get x equals 9. Make sure, again, you're using the properties of exponents. Right, again, you know the properties of exponents, but I know when you start solving things, then you just start thinking about, oh, it's division, so it's divide. I understand. You know, it gets confusing. So, questions?